So, hey there, and welcome back to our second part of the Unity introduction tutorial called Angry Cows. So, let's see. So this is basically the scene we've created in our first tutorial part. Let's move this webcam out of the scene. So, what are we going to do now? Because if we hit play, we already have this nice scene and a lot of physical objects in there, but what we want to do is move this little cannon here, or this little tube, up and down from right to left depending on the position of our mouse. And if we hit the left mouse button, we want to clone bullets and shoot them into the direction of our physics wall. So let's go out of the play mode. That's always important if you want to change stuff here in your hierarchy, or if you want to edit scripts or remove stuff in your scene view. Always go out of the play or the game mode, because otherwise these changes won't be added to your project. For example, if I'm removing something here, so let's see, it works in real time because the game is still running. But as soon as you stop the game, everything is back to normal. And that counts for all different settings we are doing here. So for example, even if we are, I don't know, moving around the floor, or if we are changing colors of materials, as you can see here, as soon as you go out of the game mode, or the play mode, everything is back to normal. Okay, cool. So let's add our first script. For that we go into our Canon tube, because the tube is the object we want to move around later on with our mouse. So we add, let's say, like a brain to our tube. So we add a component. Move everything here. Then you can click on scripts. Oh, sorry, no, that was wrong. Or you can just type something in there. Let's create a name for it. Let's call it Canon controller. And as you can see, if you type something in that Unity doesn't know by now, because this class doesn't exist, you can click here on add a new script. It's asking again if it's the name you want to use, Canon controller, and then click on create and add. Now Unity is refreshing, so this takes a little bit, and then you can see, cool, our tube now has its own script called Canon controller. This script is automatically added to the root folder of our assets. What we want to do here, just to keep it clean, is to create again a folder which is called scripts, and then move our Canon script in there. Okay, how can we edit this script? There are two ways. One way is to click on Asset Scripts and then double click here on our script. Or what you can do as well, click on the tube and then in our inspector double click on Canon controller, and then Visual Studio starts, which is our development environment for adding C# scripts. If you haven't heard about it before, the scripting language of Unity is C#. That's how one class looks like. So by default, if you add like a new script to a component, to a game controller component, what we did, a game object, then you can see that this class here is automatically generated, and there's a start function in there and an update function. What does it mean? Start is called once, so when the game object is added to the stage, or the game starts, and then there's an update function which runs basically in a loop every frame. So if you want to do something at the beginning, so for example, you want to change the position of the game object, you can do it here. If you want to do something constantly and check for example, if the object yeah, is moving to a certain point or whatever, you can do it here. So first of all, I show you the probably most powerful thing here. That's debug. So what does debug do? Debug is a class which can log out texts, variables, or objects for us. So what I did here is, just for a first test, write debug log test into our start function. We always have to save it, like click Ctrl S to save our script and then go back into Unity. Compiles right now. And these debug logs are shown here in our console. So if we hit play, you can see that tests is written down here, and if you want to check where it comes from, underneath here it even says, okay, this test was, this test string was printed out in our Canon controller class, line 10. This console is pretty powerful because if you're doing stuff wrong in our script, so if we go back into the Canon script file, and for example we are just typing in something dumb here, which doesn't make sense. If you click Ctrl S, you can already see that here's like an error highlighting in your script editor, but also here in Unity, if you want to play the scene now, it says, okay, there are compiler errors, please check these errors. And then you can just double click on the error here. It shows you exactly where it is, and then fix the error. We can do the same here in our update function, just to see how it works. Debug log, and then update. Save it. Go back to Unity. Hit play. And then you can see that there are a lot of logs going on. So basically every frame the update function is called, and our update string is printed out here. Okay, nice. If you want to check out what kind of functions you can use in Unity, because there are a lot, in this it's called mono behavior class. There are a lot of different functions attached. So in Unity, especially if you have a rigid body, for example, there are already functions you can use, like on collision enter, on trigger enter. We will see later on, and we will even use them, what they are for. But yeah, by now we just start with these simple functions, like start and update. And what we want to do now is, first of all, get a mouse position. What you always should do when coding in C# or even in other languages are writing comments. You can write comments if you are putting a // in front of it, and then yeah, you can write something like get mouse position. And this is something for you, that your code is structured, but also for other developers who are working in your project, that they know, hey, what are you doing there? And it helps them a little bit to see what we are doing. So first of all, a mouse position has an X and a Y position. So mathematically, this is a vector 2. Vector 3 has X, Y, Z, but because the mouse, or our mouse, can only move from right to left, top to bottom, we are getting a vector 2 here. We can give it a name, mouse position. It's up to us. And then we can use the input class of Unity. As you can see in Visual Studio, you get already yeah, an example of what kind of classes you can use here. We want to use the input class, then dot, and we want to get the mouse position. If you want to already check if it really worked, what we've done here, you can always put a debug log in there. And now the nice thing is you can not only put strings in here, you can also console out our mouse position. Go back into Unity. Hit play. And then you can see down here that we have an X position and a Y position, and depending on where the mouse is, these are changing. Okay, perfect. Hit Control S to save from time to time, and let's go back into Visual Studio. Now, what are we going to do with that? So first of all, we want to, let's write a little comment for that. We want to get the position of the mouse in compared to our screen size. So we want to get the relative mouse position. Again, you don't have to write all these comments down here, but I'm just doing that for a better documentation later on. And what we want to do is create a float. Float is basically a number, but with decimals. So it can be 0.5 or something. Integers are only numbers without decimals, so 1, 2, 3, whatever. But we want to have a float here that is a little bit more concrete. Okay, so float horizontal position, and that's, now we are using our mouse position, but as we learned, our mouse position is a vector too, so we can get an X position out of it and a Y position. For horizontal movements, we want to use the X position. Now we are dividing it through, that's also a Unity class, screen dot width. So now, as you can imagine, if we have the mouse on the left side of the screen, this mouse position X is pretty small, like 0. And if we go to the right, it's, for example, if you're on Full HD 1920, and if you divide it through the screen width, on the right side, horizontal position gives us the number 1, on the left side, 0. So we have a range from 0 to 1 here. We can copy and paste that and do the same thing for vertical position. Then, of course, it's mouse position Y and the screen height. Okay, now what we want to do is, because this script is attached to our game object, the pipe, maybe let's go back into Unity. It's a little bit time to deploy, okay. Tube. And this cannon controller is attached to our tube. So you can always, if something is attached, the script is attached to our game object here, the tube, you can always get the tube attributes or classes, whatever is attached to our tube, in our script here. So, for example, if we want to work with our tube, we can type in game object dot transform, and then, for example, dot position dot x, and this will be the x position of our current tube object. And what we can do as well is transform maybe rotation to rotate it, or we can also get material attributes and change them, and so on and so on. So what we want to do now is we want to move this this pipe, and or not move it, we want to rotate it through x and z axis. So first of all, maybe we create a float here, or maybe first a comment. So how do you want to call it? Rotate tube based on mouse positions. And now, first we create a float. which we call degree angle. And this one, let's set it to 30.0 degrees. And now let's define two rotations. So one horizontal rotation. And this one should go from -30 to +30 degrees, depending on our horizontal position. How can we do that? So first of all, we start with -30 degrees, so minus degree angle. And then we add our degree angle times 2, because we want to go from -30 to +30, so it's degree angle times 2. And then multiply it with our horizontal position. Because as we said before, horizontal position goes from 0 to 1. So this whole rotation goes from -30 degrees to +30 degrees. If you want to change it later on and make the cannon move a little bit more, you can even change it to 45 and so on. So we have a horizontal position. Let's do the same here. Control Z, Control V, and call it vertical rotation. Degree angle, that's fine. And then use, of course, the vertical position. Awesome. So now we have 2 degree angles. We just calculated. What we want to do now is move our game object. And we can do that by call game object dot transform dot local Euler angles. So this is the function we need to call here, because normal rotations are defined in quaternions, what we do not want to use here because we have degree angles, and so we can just use local Euler angles instead. Local always means that the rotation is relative to our object. So it doesn't matter if the object is inside of another container, which is already rotated around 90 degrees. It only checks what kind of degree angles our object has, and we can manipulate these. This rotation is also vector 3, because we have X, Y, and Z here. So first vertical rotation, Y can stay like it is, 0, and then horizontal rotation. Okay, let's set that script. And now let's go back into Unity. Maybe let's clear the console. Can do that by clicking on this little button here. And now let's press play and see if our script works like expected. And as you can see, I'm moving my mouse. It's turning right and left, moving it up and down. Tube moves up and down. So perfect. This is our first step, our first interaction. Now, let's go further with it. What we want to do now is to check mouse press. And for that, we can use, first of all, an if statement. You probably know from other scripting languages. So we are checking if input, Unity class we can use, get mouse button down from 0, this is the left mouse button. When this function is true, then do something. And what we want to do is emit a bullet. Okay. How can we do that? First of all, we need a reference because, as you can remember, we made a prefab out of our bullet, but now we want to get this prefab into our script here. And what you can do at the top of our class is define public variables or public objects. What does it mean? Let's start simple. Let's add a public float here. And let's call it maybe degree angle. And you can give it a default value of 30.0. And now we can use this degree angle here at the bottom. So we can remove even that variable here. And what it does is, if you go back into Unity, because this is set to public here, a public float, you can use that variable inside of our Unity UI, which is pretty nice. Because now you can see we can change this degree angle here, like you can change in other classes like transform the XYZ position. We can change variables in our own script. So for example, if we move that, or we change that now to 90 degrees and play the scene again, our tube is moving way more to the left and right, because now it can move around 90 degrees. Let's put it back to 30. It's a little easier to handle. And what we want to do now is do the same with our rigid body, so with our bullet. So what we can do is public rigid body. Let's call it bullet instance. And then we can use it down here. And what we want to do, we create a new rigid body every time the mouse is clicked. So rigid body, let's call it new bullet instance equals, and then there's a function in Unity which is called instantiate. And what we can do with that, it basically clones objects. So if we are cloning our bullet instance, it creates a new instance of our bullet and places it on the stage. Because we do not want to place it somewhere, we can, with a comma, also tell him what kind of transform or what kind of position this instance should be added. And then we can use our game object, so basically our tube dot transform dot position, and then this instance is added to the stage exactly where the pipe sits. So we need a little bit more here as well. This is for the rotation. So what we are doing here is basically adding a null vector for our rotation. This is a vector 3, and then 0, 0, 0, because rotation doesn't really matter. And that's the first part. So this is already pretty nice, but as you can imagine, we can try it out in our Unity scene already. So if we click on it, yeah, if you try it out now and you click onto your scene, you're seeing that we are getting an error here. So what it says is that the variable bullet instance is not assigned by now. What does it mean? If we go to the tube, you can see that we add a bullet instance variable here, but it says none, no rigid body. So our bullet script or Canon script doesn't know what kind of instance the script should add to our scene. So we can go to our prefabs folder, and then you remember we have the bullet instance here, and then just drag and drop it into our script here. We can clear the console again, press on play. And then we see, okay, it's more or less working. Of course, there's no force at the moment, and the bullets, just fall to the ground. And we see that there's another problem because the tube has a collider as well at the moment, and so the clones of our bullets are somehow pushed away from the tube, and all of our bullet clones are just pushed to our main scene. So what we want to do here is add a container as well, that they are all nicely wrapped together in one game object and not just floating around here. Okay, so first of all, what we want to do is create an empty game object here. This is called bullet container. And then second step, like we said before, the collider script on our tube, we do not want to have it anymore, so we can remove this component. Okay, save it. Now let's go back into our script. So we want to add a public game object here on top. Sorry, I think it needs to be a transform. Transform and call this bullet container. And this is the variable we can add later on in our UI. And then if we separate this here with comma, it's asking for the parent object, and this needs to be in transform. So this is our bullet container. Okay, nice. Now let's add some shoot power. So we can define a float by ourselves. Let's call it shoot power and give it by now a value of 50. And what we need to find out now is the direction of the pipe. And this is a vector 3 again, because the direction of the pipe points somewhere into our scene. So this is a vector 3, pipe vector, you can call it. And the vector we can get from our transform position. So this is, if you want to know, or if you want to dive deeper into vector and math calculation, you can look it up. But just as a short introduction, this vector is or has always a position, so a start position point. Then it's pointing somewhere, and in our case, we want to point it to the direction our game object transform up points to. So basically, our pipe in the direction the pipe is facing to, and then there's always a force attached, and that's our shoot power in our case. So again, we have a position, then we have a position the vector is facing to, or a point the vector is facing to, and then a shoot power. And what we can do now is give our new bullet instance here, because it's a rigid body, a velocity, and velocity is always defined by this vector, and so we can use the pipe vector for that. And now we should be ready to go. Let's save it, go back into Unity. Let's hit play. And here we go. We can shoot on our wall. If you want to change the mouse behavior, because right now for me it's more or less like I'm dragging the pipe, but if you want to change it, you can just change the X and Y position. Okay, and that's basically the first fundamental of our game. But as you can remember, we've defined this bullet container here, but we've not attached it by now to our tube. That's why all the instances got added to our scene. So here the bullet container is still none. So we can add it here. And then if you hit play again, all of our bullets are added to our bullet container. That's pretty important because later on we want to check inside of our bullet container how many bullets maybe are there, to count them, or maybe to check if they are still inside of our scene, to remove them. Yeah, that's something we're gonna do in the next step. Okay, so first of all, thank you for watching the Unity part 2. In our part 3, we want to add some additional scripts so that we have a little bit of game logic in there. We want to add this little UI panel here on top, so that you can see how many bullets you've already used. And yeah, from there on, you can even add more functionality in there. We will use colliders as well. Sorry for that, something fall to the ground here. We'll use colliders as well and collider scripts to check if the cows hit the ground or not. But yeah, that's something for the next part. So thanks for watching.